Establishing argument validity deductively. Let's take a look at these three inference rules. Modus tollens states that premises P implies Q and negation of Q conclude negation of P. The constructive dilemma states that premises P implies Q, R implies S, P or R conclude Q or S. Destructive dilemma states that premises P implies Q, R implies S, negation of Q or negation of S conclude negation of P or negation of R. Our goal in our presentation is to establish inference rules such as this in a deductive fashion. Before we can begin, let's review some logic identities. And let's also review some inference rules. So we have modus ponens, conjunction, simplification, amplification, disjunctive syllogism, hypothetical syllogism, and absorption. In establishing an inference rule in a deductive fashion, we're going to begin with some logic identities and some inference rules. We're going to assume that they have already been established, and then what we're going to do is we're going to establish the new ones by taking our premises using known logic identities and inference rules that have already been proven to arrive at the conclusion. Now, for now, we're going to assume that the modus ponens, the conjunction, the simplification, the amplification, the disjunctive syllogism, the hypothetical syllogism, we're going to take those for granted. We're going to assume that they have already been proven. We're not going to assume the absorption rule because that one we intend to establish in this presentation. So let's go back and illustrate how to establish modus tollens in the constructive dilemma in a deductive fashion. So let's begin with modus tollens. So, proof of modus tollens. The way we proceed is we write assertions and justify them. So on one column we list our assertions. In another column, we provide justification. So let's begin. What can we assert in modus tollens? Well, we can assert P implies Q. Why can we assert that? That is a premise that is given. We can also assert negation of Q. Again, it's given. Now, as we proceed, we want to reach the point that we are able to assert the conclusion itself. So we want to make progress up to the point where we assert the negation of P and we're able to justify it. The moment we reach this stage, we have completed our deductive proof of modus tollens. So let's see how we can get there. let's observe that P implies Q is logically equivalent to the negation of P, the negation of Q implies the negation of P. What justifies that step? The step that P implies Q is logically equivalent to negation of Q implies negation of P. Well, that is one of our logic identities, the one known as a contraposition. Now, in writing our justification, we want to pinpoint where it took place. We want to make a reference. This took place in step 1. We changed P implies Q into negation of Q implies P. That was from step 1. So we're going to list the justification and reference to where it was applied. Now, what else? Let's take a look at what we have in steps 2 and 3. Let's pretend that the negation of Q is A, and let's pretend that the negation of P is B. So what do we have then? Well, in step 3 we have A implies B. Notice that in step 2 we have A. So if we have A implies B and we have A, what can we get from that? Naturally, we will get B by modus ponens. Observe that B is actually negation of P. Justification, we have applied modus ponens. Where did we do that? In steps 3 and 2 in that order. And we're done. Remember, this was our goal. We reached a negation of P and we justified it. Okay, so this is a simple illustration of establishing an inference rule deductively. Let's try one more. Let's now establish the constructive dilemma. Proof of the constructive dilemma. We'll just say it that way. Before we start writing assertions and justifications, let's pay attention to this third premise. We're asserting P or R holds. If we assert that P or R holds, then we must have that at least one of them, at least one of P or R actually holds. So the premise P or R allows us to conclude that at least one out of PR holds. So let's assume it is P that holds. So assume it is P that holds. Notice that we are not losing generality. If it isn't P that holds, then it's R. In the argument that we're about to present, either of the two assumptions, that P holds or R holds, will allow us to get what we're after. What are we after? We're going to take our givens and we are intending to obtain our conclusion. So let's begin. Step 1. Let's assert that P implies Q. That's given. Let's assert that R implies S. That's also given. Now, let's assert P, because we're assuming that. This assumption is founded. You do have to be careful when you make assumptions. You do have to be careful. You do have to have merit for that assumption. In this case, if it wasn't P, then it would have to be R. If it was R, you would write it here and then you will proceed. Regardless of which one it is, you will be able to reach your conclusion. Four. Now let's note immediately that steps 1 and 3 allow you to conclude Q. P implies Q. P, therefore Q. That's just modus ponens. Modus ponens apply to steps 1 and 3. Now notice that so far we have Q, we're after Q or S. Can we get Q or S? We can if we apply one of our inference rules. The one we're thinking about right now is amplification. You have premise A, then you can conclude A or something else. So if we have A, you can conclude A or B. The B being the something else. So in this case, we will say that we get Q or something else. Well, the something else we're interested in is S, so let's write it. Your S. Reason, the inference rule of amplification. Where did we apply it? In step 4. So our proof of the constructive dilemma is complete. Notice that this is also a straightforward proof, but we did have to prepare our ground. Before we wrote our proof, we did exploit one of the premises in order to make the proof as simple as possible. Let's exemplify one more time. Let's set out to establish one of our inference rules, the very last one in our list, which was absorption. Alright, so proof of absorption. Only one premise, so let's write it. Step 1, P implies Q. Let's assert P implies Q, because that's given. What can we say here? Well, we have a logic identity that says that A implies C is logically equivalent to the negation of A or C. We're going to apply this identity. In this case, of course, we're going to write negation of P or Q. Justification, well, we have that identity. It does not have a particular name, so in this presentation, we're going to pinpoint to it. So this is our justification, that identity, the one that writes a conditional as a disjunction, and we're applying that to step 1. Now we have to think ahead. What is that we want? We want to establish P implies P and Q. That's our thought process. We want that. We want to make this assertion eventually and justify it. Notice that it will suffice if we establish negation of P or P and Q. Why is that? Because of this identity that rewrites a conditional as a disjunction. This conditional is logically equivalent to that disjunction. So if we arrive at this conclusion, we are basically arrived at the one we want. Now let's see what we have out of this in here. We have the negation of P part, but we're lacking P in the second component of the disjunction. So we are going to attempt to introduce a P. Now let's take a look at a fact. If you take the conjunction of a true statement and A, you get back A. That's an identity. That's the identity of conjunction. True is the identity of conjunction. So let's try that in here. True and negation of P or Q. Why is that? That's the identity of and. We are using step 2 in this conjunction. It doesn't seem to be very intuitive, but there is a purpose for putting this true here, this truth value of true. We can now extract a P from it in the following fashion. If you take negation of P or P, that is logically equivalent to T. It is a tautology. Negation of P or P is a tautology. That means this is true, always, regardless of whether P is true or false. So how does this, here we're going to say that this follows from definition of disjunction. There might be a better way of referring to it, but right now for the purposes of this presentation, we're going to pinpoint that follows by definition of or. If you take two statements which are opposite in truth value, when you take their disjunction, you will get the truth value of true always. Now this is somewhat clever. How do we think about rewriting a true as negation of P or P instead of writing it as negation of, let's say, Q, negation of Q or Q, or the negation of S and S? How do we think that it has to be negation of P or P? Well, if we do that, we start noticing some logic identity which will lead, believe it or not, to what we're after. Let's notice that this is the distribution of negation of P or P and Q. Let's examine. If you distribute a negation of P or P and Q, we're distributing or over and. What do we get? Negation of P or P and negation of P or Q. Exactly what we have in step 4. So we're making use of the distributive law of or over and, one of our logic identities. So we'll just say distributive law. One of the distributive laws applied to step 4. So there we have it. We have reached what we wanted. Formally, we would like to write now P implies P and Q, and quote the reason A implies C is logically equivalent to negation of A or C. Reason down here. Where did we apply that? In step 5. So we're done. We've proven the law of absorption. This concludes our presentation on establishing argument validity deductively.